Yo. And you get the little button I think that you have to agree to because it's being recorded. So hey everybody, welcome to the Dallas-Fort Worth Spice Corps virtual meetup, June 7th, 2021. My name is Nick Cordy. I'm one of the co-leaders of the Spice Corps, and we are technically part of the Dallas-Fort Worth area group that meets in person, but we haven't done that since COVID started. We'll probably look at doing that maybe late this year sometime. But in this particular case, we have a guest that was able to join us remotely that otherwise would not have been able to do so if we had been meeting in person. So a couple things I want to tell you. If this is your first time joining a Spice Corps group, let me just tell you what that is. So Spice Corps was founded in the SpiceWorks community, which if you're not a member, you can join for free. It's a bunch of IT question and answer forums on any topic you can think of I call it for the IT generalist, but really it can help anyone. And they had a conference that started in around 2008 timeframe, or actually, yeah, I think it was 2008. Spice World, right? Nothing to do with the Spice Girls. All these people met in person. They were talking about the SpiceWorks software that's free for help desk and inventory, and they wanted to start having meetups in their areas, and that's how the Spice Corps groups were founded. They originally started talking about the SpiceWorks software, but it grew into an IT pro networking group that is really more of an IT generalist group. So we talk about everything under the umbrella. We've had people talk about best practices and getting refurbished gear or recycling your old hardware. We've had people talk about how they implemented a wireless solution for their business. We're going to have David talk about, SQL Server this evening. So if you want to get alerts when this particular group has meetings, you can actually join the SpiceWorks community for free and start following the group. I'll put some instructions in the chat. Important dates, if you're a member of the SpiceWorks community, would be September 27th through the 29th. That is the Spice World Virtual Conference. I think the sessions are still going to be, people are still voting on what they want to see for sessions. And if you want to contribute to that voting, there's the link of potential sessions that could be happening at that conference. Once again, completely virtual. I know some events are looking at going back to in-person later this year, like VMware User Group is, I believe, and some others, but that's going to remain virtual. So here's what I'm going to do. Without further ado, I'm going to hand it over to David, and he's going to talk to us about all things SQL Server performance for the IT Generalist.
Very cool. Thank you for having me. And I have to say, thank you all for being willing to jump on after hours like this. This topic is one of those that is near and dear to me. I'm gonna rename this the Sysadmin's Guide to SQL Server Health, but it's basically you inherited a SQL Server when you walked into your job, and now we have no idea what to do with it. But you're tasked with keeping this thing running. So what do we do? So a little bit about me. I am the founder of SQLibrium Education and then the founder of Heraflux Technologies. I'm lucky enough to be a Microsoft Data Platform MVP and a VMware vExpert. It basically means I get to give a little bit of feedback to help hopefully steer some of these things into more of the direction that I think would make life better for everybody. It's kind of fun. My background, I was actually a system administrator for a long time, and stumbled into being a DBA and found out I really enjoyed it, but I always kept my hands dirty with the infrastructure side of the house. And right place, right time, I actually authored the SQL Server curriculum and guidance for partners for how to virtualize SQL Server a long time ago. Been helping out with their best practices guide ever since. And this topic is one of those areas that I have a blast with. So do not hesitate to interrupt me, yell. If we were in the same room, I'd say throw something at me. Whatever we need to do, I don't want to leave here until your questions are answered. And this is going to be recorded and up on YouTube. And if anybody's watching this after the fact, my contact info is on the screen here. So please don't hesitate to reach out to me. It may take me a couple days to get back to you, but I will definitely do so because I'm a geek. I love this stuff. I heat my house with my home lab. I have a lot of fun with this. So we're going to laugh a little bit. We're going to have some fun. Okay, so step number one here. What the heck is SQL Server? What does it actually do? What layers does this thing tackle on the infrastructure? We've got some availability pieces we're going to discuss in brief. And then just what are we looking at? What the heck are we doing? How do we get in and actually make sure this stuff is running well? We're going to talk about Perfmon. or the equivalent if you have some third-party tools out there. Then we're going to talk about how to look at the instance level of SQL Server, and then routine maintenance at the instance level, which is absolutely critical, and it gets a lot less love than I would like. And then we're going to talk about the TempDB database and just how critical it is, and quite frankly, how people kind of abuse it. And then we're going to talk about the user database level. And it sounds like a lot of gobbledygook here, so do not stop, or do not let me keep going if there's something you don't understand. Again, yell, shout, whatever we need to do. Okay, step 0. What is SQL Server? Well, it's a relational database engine. You may have heard things like NoSQL or a lot of the open source stuff like MySQL, Postgres. It's yet another database platform, arguably one of the ones that's a little more used in the world. I love it, partly because of the community, partly because of the technology. It's pretty darn solid, and quite frankly, it's everywhere, which is probably why we're all here watching this presentation tonight. It's not just the database engine. There's actually a lot of pieces to it. So the biggest piece that people know about, it's the relational database engine. So this is what allows us to store and retrieve the data. It gives us the ability to transform it, query for specific data that we care about, and store it in the way that's really meaningful to us. There's also a mechanism in there called SQL Server Integration Services, or SSIS. And this is how we can move data around, like push it from this machine into other things, or pull it from other data sources, maybe flat files, maybe, different web services. You name it, we can pull it in and manipulate it here and just transform it in certain ways. There's also a data analytics engine and a reporting engine. So it's called SQL Server Analysis Services, and that's really your data warehousing solution if you want a formal data warehouse. Keep in mind, a lot of people have a relational database and they call it a warehouse because they do reporting out of it, but they're a little bit different. The end goal is the same thing. We just want to get data and business value out of it, but people can go about it a bazillion different ways. There's a reporting engine called SQL Server Reporting Services. Fairly straightforward. I'm not going to touch on a lot of this stuff for this session, but keep in mind that it's not just SQL Server that may be present on these machines. And there's also something new called big data clusters, and it's there for helping people record and deal with big reports. And we're talking pretty big scale out environments. Now, between you and me, and I know this is going out to the world, what is SQL Server really? It's the thing that's going to eat all your storage. It's the thing that's going to eat all your RAM. And it's the thing that's going to eat all your CPU. That's the bottom line. And there's very good, legitimate reasons why it does this. But keep in mind, it's going to eat a lot of CPU time on average. It is extremely sensitive to CPU penalties, meaning maybe some virtualization misconfigurations, maybe virtual machines are just being overloaded, maybe we got power savings set incorrectly. There's tons of things around this, and I'll talk about some of them here. But just keep in mind, don't blame your DBAs for this, not until you have more stats, but it's one of the bigger resource consumers in your environment. Okay. Every single thing that SQL Server does is going to push your infrastructure from the top to the bottom and back to the top. So if you take a look at this, whenever a DBA changes data, it goes into the database, then into the instance. If it's running in a container, it's got to go through that layer. The operating system then has to figure out what to do with it. It wraps with the virtual machine layer, pushes through networking to get to converged storage or hyper-converged or SAN or whatever you want to do with it, through the physical machine to the storage and all the way back. This platform can push your environment really hard. And I know you all know those, but I'm going to reemphasize this. It's extremely sensitive to delays in the infrastructure. I'm going to show you how to actually go and detect a lot of this stuff and what to do about it. There's a handful of acronyms just so we can get them out of the way. Okay, SQL. SQL is a communications standard for relational databases. SQL is not a product. SQL Server is the product. Some DBAs are really picky about the nomenclature here. So if you don't want to be immediately dismissed by some of these DBAs, call it SQL Server and not SQL. I know I'm sounding very pedantic here, but just be careful with that. Now, a SQL Server installation is called an instance. It's a running copy of SQL Server. You can have more than one of these on a machine, but just keep in mind, it's not just a database like an Oracle machine or some of the others. You can have multiple databases on an instance. You can have multiple instances on an operating system. The SQL agent is our job scheduler. So this is the thing that says, run my backups every night at 10 p.m. Run my index maintenance every night at 3 a.m. Give me integrity checks every Sunday morning at 5 a.m. You know, whatever you want with that. This is the way you can schedule this thing to do certain tasks. If you hear me use the acronym SSMS, this is SQL Server Management Studio. This is the primary interface for people to actually get in and query your environment. And it looks kind of like this. If you've done anything with SQL Server, this is probably pretty familiar. Now, there is I don't want to say a replacement, but another querying tool being developed by Microsoft. It's currently still under development, but the beta is open. It's completely usable. It's called Azure Data Studio, and don't just think of it as Azure. You can get into SQL Server with it. You can actually get into Postgres with it, but it's not feature complete to SSMS yet. But it's pretty darn powerful for what it is. It actually starts faster. I like it. I'm trying to transition my brain into using this, but I've been using Enterprise Manager and then SQL Server Management Studio for 25 years now. Good grief. So just keep that in mind. Now, the last one here is DMV, and this is not the Division of Motor Vehicles because we all hate that. This is actually SQL Server Dynamic Management Views. And essentially, when you want to ask SQL Server, what is it doing? What's it thinking? What's it waiting on? This is what we're going to query. And these are tons of built-in dynamic management view introspection to get to all these key statistics that the database engine is storing and keeping in memory, and just basically sitting there waiting for you to ask, what's the pain point? What's the bottleneck? The hierarchy on this stuff is really interesting. So just to lay all this out there, we have an operating system. I'll zoom in and zoom out. We have an operating system, can be Windows. Believe it or not, SQL Server can run on Linux now, which is really, really cool. We have the instance, which is essentially our installation. The default instance means we can connect to it just by typing in the machine name. Now, we may have a named instance. Some DBAs like to do this. Some third-party software loves to do this, kind of like Veeam. So instead of connecting into the machine name, it would be, the computer name / instance name, something like this, and that's how you connect into it. Now, for each instance you have one or more databases on there. So in this case, DB1, DB2, the named instance has only got the one over here. Each database is made up of what are called file groups. And most of the time, what you see is default. Occasionally, people can have more than one. There's a lot of good reasons for that. For smaller databases, meaning 50 gigs, 100 gigs, it's probably not that important. For bigger ones, though, these can get pretty big, and I'm not exaggerating when we've got one database that we work on that is 741 terabytes. One database. You're not going to do that in a single 741 terabyte file. They've got, I want to say it's like 6,000 data files and like 400 or 500 file groups across multiple SANs. I mean, it's just ridiculous, to be honest. Now, we've got data files, and if you ever see the MDF or the NDF, this is where the data for the database resides. And then there's this thing over here called the transaction log, or the LDF. I'm going to go into that here in a minute, but that is not a normal log file. It's not anything that you can just disregard and ignore. This is actually something very critical to the SQL Server. Every single bit of data that changes in your environment gets written into this transaction log, and it has to be managed very carefully, or else it can either grow out of control, or if it's not there, you just lost a bunch of data. None of that is good. And then, because I'm an infrastructure person, I like to spread out the database workloads. So if it's a tiny database, it doesn't matter. But I mean, if we're talking hundreds of gigs or bigger, you're going to want to start to spread these files out amongst multiple operating system volumes. If you're in the cloud, multiple virtual disks. If you're on-prem, multiple virtual disks, multiple disk controllers. Same thing goes for all of those. cool. I see a bunch of things popping up in the chat here. Are there any questions on any of this so far?
No, no questions.
Okay, cool.
Not that I've seen.
Okay, cool. Now, if you take your database, and I'll just show you over here, if we literally just pick a database, so this is SQL Server Management Studio, expand databases, you'll see a given database. I think I'm going to use this one because that's kind of funny. So I'm going to zoom in here. What you end up with is the database properties. So you can see, yes, you can name an emoji as a database name. Please don't do this in production, but for pre-production systems, it's hysterical. If you click on files here, I'll zoom in and out so you can see this. This is where we start to figure out where everything is at. There is a logical name that corresponds to each file in the file system. You can figure out what file group it's in. You see this says rows, that says log. The log file does not get a file group. You should only ever have one log file for a given database. You may have multiple files here for data files for the database. And you can see this is toilet.mdf and toilet_log.ldf. Again, the log file is extremely important here. Now, the bigger the database and the more astute either the ISV or the DBA, you may see more files here. And you can see from the slides, that's kind of what I have here. And this is a database that I created. You've got 4 data files. You can see the primary is MDF. All the secondaries are NDF. Now, this is located in the same folder here. It's because it's actually on my desktop right now, and who cares? You know, if this was production, I certainly wouldn't do that. There's our log file, the LDF. The log file is not a normal log file. I'm going to repeat that again and again and again. We have to manage this properly. Now, an interesting thing here, has anybody ever wondered why a lot of the core DBAs out there tend to argue with system administrators about what SQL Server is actually doing? And feel free to either put it in the chat window or speak up and just say yeah or no. And if you say no, I'm just going to say your DBAs haven't been truthful with you. The reason for this is because there's actually a little tiny operating system built into the database. It's called, go figure, the SQL OS. It's a self-contained database engine for things like CPU thread management, storage activity, memory management, multi-threading, all this stuff. Believe it or not, it only contacts the underlying operating system for roughly 45, 46 different operations. Everything else is all self-contained inside this engine, inside that SQL Server.exe process. This is why when we look at VMware, the active memory counter is not accurate. This is why when we look at Windows level memory stats, we can't tell what the database engine is doing. It's not really trying to hide it, but it just doesn't talk well with some of these other pieces in there. That's why we got to get into the brain of SQL Server to figure out how this stuff is actually being used and actually working. Now, what the heck is SQL Server for Management Studio? What are we looking at? Because I mean, this looks dull, boring. There's a lot of stuff in here. Okay, step 1. That is your instance. Now I'm connecting to it from the local host. Otherwise, it would actually say your name here. Now, there's something I'm going to highlight here, and then I'm going to zoom in on this in a little bit. There's a number right here. That tells me this is SQL Server 2019. This tells me this is cumulative update 10. And I'll show you here in a minute where to go check for this, because Windows Update does not update any of this stuff. Okay, these are your user databases. That is the query or the command. It could be what's called a stored procedure call. It could just be a straight query, kind of like what you're seeing here. Stored procedures just execute this stored procedure by name, maybe pass in some parameters, but all the logic in there is packaged inside this thing. Now, this is what's called a result set. Every time you run a command, if it returns something to the user, it'll give you that number. Like this one, I'm saying, give me a count of everything in the time entry table. This is our little CMS on the back end. I actually go look to see how many entries. In my little consulting company, we have 19,000 time entries in there, which, geez, I've been busy. This down at the bottom tells you where you're connected. It is really easy to accidentally have the wrong machine selected if you go to execute a command. I know this because about once a week we get a call from one of our customers saying, we accidentally deleted something in production. Can you go recover this right now? Which is awfully helpful. So just be very, very careful that you're running whatever you want to run against the correct server, because if you don't, it could be really terrible to try to go repair and clean up. And sometimes if you don't have your backup strategy set right, it's gone. And that's not a good day. Okay, the SQL Server agent that I was talking about, this is down here at the bottom. This is where your job scheduler is at, and I'll zoom in there here in a minute. These are your logins, and the way the login works is that you define an instance level login. It's actually called a user, and it says this user has access to these databases or this level of permission to the instance to actually do things like kick off backups or see all my properties here, or even basic stuff like just let me have access to these dynamic management views so I can see what's going on. It's called view server state access. You can get extremely granular with this. Please don't give all your users God access. That would be bad because then somebody can delete something and that's really terrible. Be very careful with this. I'm not going to put on the marketing hat, but there are a lot of really good consultants in the industry. If you're curious about where you stand with this, it's actually something we don't do, but I can point you in the right direction with people that can do a SQL Server level security audit and go figure out if things are okay or not. We've uncovered 3 customers now where by accident, all of their employees, including janitors and cafeteria workers, could get in and drop everything in the database and just delete everything if they knew how. They got lucky, nobody did, but the access was there, and that's scary. There's a bunch of other stuff here, which I have ostensibly labeled other stuff. Most of the time, we don't have to go worry about that. That's things like our SQL Server high availability solution. There's integration with something called Polybase into other systems. There's link servers and things that copy data around to different machines. Most of the time for a health check, you don't have to worry about any of that. Now, there are system databases here that are extremely important. And it's one of those things we want to make sure that we're backing these up in addition to our user databases. There's the master database. And this contains things like, who am I? What configuration do I have? What logins do I have? What are just some of these basic settings? There's the model database, and this is basically a placeholder. Every time you go right-click, create a new database, this is what actually gets copied and becomes your new database. There's the MSDB database, and that is the thing that stores all of my jobs, all of my alerting, all of my email configuration, all that kind of stuff. And it's really critical because if you're sending a lot of emails with SQL Server, you may start to fill up the MSDB database. And if if you aren't backing it up properly and then the poop hits a fan, all of your jobs just disappeared, and that's not good. And then there's the TempDB database. The TempDB database, think of it as the garbage can. This is one of those areas that if I'm doing heavy sorts, I may need to write something there. And that way I can dump everything in there and then sort it and then send it back to you. If I don't have enough memory to run an entire query, I may actually use that as a temporary dumping ground. And the database engine does this. You don't necessarily have to worry about it, but it just uses it. And every single time you restart SQL Server, it actually copies the model database and recreates the TempDB. So for all of you doing virtual machine level replication, say with things like Zerto or vSphere replication, why replicate that? It's a lot of data that's changing, and sometimes we're talking petabytes of data change. We don't need it. Yeah, there's one, if you're using Zerto, you can right click on the virtual disk and say mark as swap drive. It copies the disk and the folders, but not the files. We were able to cut somebody's MPLS circuit bill in 70% because of how heavily their TempDB was being used and how much data it was consuming to replicate, and they didn't need to replicate that. Minor things like that can go a long way to making this thing more efficient, saving you money, and honestly, making the phone calls ring less so you can actually get stuff done. Okay, now step 1 for me, any place that I walk into, if somebody says this isn't running well, I always say, well, how is it running when things are running fine? Nobody has a baseline of anything, and I'm going to harp and preach about this, but bottom line, you as an administrator of these machines, we need to have a good understanding of just what this thing is doing day in, day out, and I need to know, is it just freaking out, or is it quiet, or is it active but not that bad? We need to have all this. I need to understand the actual consumption of the machine. And part of this is because, from a virtual machine standpoint, I want to right size this stuff. If you're in the cloud and you've allocated this much and you need this much, you're paying for this much. I mean, there's one that we decreased. They were 12 grand a month in the cloud. We dropped them down to a VM that was $800 a month that ran better than before, and it saved them the money. Stuff like that. Third-party utilities, if you have things, and I know right now SolarWinds is really a bad kind of a faux pas kind of word, but if you have something that is collecting in-guest level performance statistics, so SCOM, PRTG, any of the SQL Server tools like SQL Sentry or SolarWinds DPA, Database Performance Analyzer, or Redgate, there's some really good utilities out there that can give you a lot of this information. The analytics might be a little limited, but you can work around that. Now, the way I look at it, most of the time we don't have these third-party utilities. We don't have the budget for it or the time to deal with it, but there is something built in. Chances are your SQL servers are running Windows, so let's use Windows Perfmon. If you've never played with this before, and I'm really hoping you have, collect it 24/7. If somebody says things are running slow and then you go turn it on, it's too late. So I like to collect it around the clock. Collect it at 30-second granularity. A lot of tools out there will actually go and it gives you 5-minute granularity or 15-minute granularity. And the way a database engine works is that when somebody issues a report, it's going to push until all this is done. So we need the highest amount of granularity that actually matters. And to me, a 30-second means you're not going to be slowing the machine down that you're profiling, but it's giving you a good enough rate of info that you can actually tell patterns and usage patterns. There's a really good question that just came in at the chat. How do you exclude tempdb while using vSphere replication? And is that keep tempdb on another disk and exclude that VM disk for that VM in vSphere replication? That is exactly it. There's no good way to do what Veeam or what Zerto does with mark as a swap disk. But basically, what I would do is basically build the VM, copy that virtual disk to the destination. And then with vSphere replication, just don't replicate that disk. And when that fails over, if you ever need to fail over, just connect to that disk. Put it as part of the run book for how to fail this thing over. And that could be anywhere from 5 to 50 or higher % of all of your IO that was going to be replicated, and you'd save all that. So makes sense. Okay. If you've never set up Perfmon before, there's no strings attached. There's a document out at our website here, hfx.te or hfxte.ch/perfmon. No strings attached. It's just literally linked to a PDF. This shows you how we like to set up Windows Perfmon for 24/7 collection. Nothing fancy. It's got all the core counters in there that we care about. If you're running VMware, it's got a few extras. If it's a SQL server, it's got some extras. If you're Hyper-V, it's also got some in there. Now, everybody on the internet says collect Perfmon data. Nobody tells you what to do with it. So we're going to fix that. About 2 years ago now, we actually released a utility out to GitHub, and it's PowerShell, and it's BLG to SQL. And what we do is if you point this thing from a command line to the locations that you're storing the Perfmon data, it can import that data into a SQL Server database. And the full directions are there. And now we got the raw data. And now work with anybody in your environment, or you can tinker around with SQL Server or honestly any other analytics tool that you want to use. And you can run this stuff nightly and get all the data that we care about and then analyze it however you see fit. And I'm going to show you a couple of things that you can do with this. And this is literally just a little bit of T-SQL with some examples that are out of GitHub and Excel. Nothing fancy, no extra cost with all this stuff. This is a normal day in one of our customers. It's a 10-core SQL server, and you can tell people get in to start using work about 7 a.m. The bulk of everybody gets there about 8:30. Yeah, I'm just going to draw on here for a minute because this is kind of fun. So people get in between 8 and 9, steadily warm up and get work done. and then they take a break. So I'm not sure if this is like the national smoke break time for this company or what. And then things calm down. You can kind of tell people do a little bit more when they get back from lunch, and then work gets done. And then at 4:30, boo, that is a ghost town by 5 o'clock. Well, actually by 4:30 right there. Now, there's a group of people at this company, I actually know them pretty well. It's a second shift of people at a manufacturing plant. They work steady. At 6 p.m., they are out the door, gone. So if you take a look at that, starting at 6 o'clock, this sucker is quiet. There's a process running that's a scheduled task inside SQL Server running at, what's that, about 9:30 at night? Nice and quiet. There's an additional block here at about midnight. There's something else running about 1:15, 1:20 in the morning. And then this spike right here at 4 a.m. is something big across all CPU cores. Only lasts about 15 minutes, 10 minutes, something like that. No big deal. But it's really interesting. You can start to get a really good sense. What's the footprint of resource consumption from this machine? You can do it for CPUs, you can do it for memory thrash, you can do it for storage consumption, network traffic, all kinds of good stuff. It's kind of fun. The processing windows, just like I said, identify what these windows of time actually are. Because let's just say, I mean, no exaggeration, we had one environment, they were killing $1 million all flash SAN every night at 8 p.m. I mean, literally 2 petabytes of NVMe storage that was running at 100 to 250 millisecond latency for 15 minutes a night. And what had happened was their DBAs didn't want to micromanage a particular index maintenance rebuild that you really do need to run every night. So they just scheduled them all to run at 8 p.m. every night on 400 SQL servers. The storage contention at the SAN was so bad that everybody in the entire environment suffered. Well, identified it just literally by looking at this, just going, what the heck is going on? And they told me, it's like, well, how long do you have to run this? Oh, about 8.5 hours. Then why start it all at 8? We don't want to micromanage multiple schedules. Like, okay, the fix for it was we edited the global index maintenance job and we put in step 1, which was give me a random number between 1 and 240 and wait that number of minutes before you go to next step. We had a perfect bell curve after that. No problems. The SAN was able to handle it just fine. You know, low-tech solution to a high-tech problem. Problem solved. Worked. I've also done a DR solution for somebody with a 16-ton granite rock, but I'll save that for a different story. Now, the time sensitivity on this stuff is really interesting. It all goes back to that same pattern in there. This sucker's running for about 15 minutes, but if you notice, they had about 2.5 more hours to let this thing run before people started getting to work. So if I'm looking to size this thing for CPUs, and by the way, you are paying for your licensing by CPU, do I need everything that's been assigned here? No. If that 4 a.m. process takes 15 more minutes to run, does it matter? It might, but it might not. And that's why you got to ask them. Figure out what that process is actually doing. There's some environments where these things are running financial data and sending it to another system for financial reporting or credit card reconciliation or things like that. You got to be careful. Other times, I'm running a backup. Ooh, it doesn't matter. CPU consumption can always get really interesting. Most third-party utilities that track the stuff will give you an average. If I looked at an average for this 6-core SQL server, would you have ever seen that one of these processes was running single-threaded? No. Look at this stuff by core. Perfmon will give you the granularity. Things like SCOM, some of these other programs will give you the granularity if you configure it. And look at this. They were running it every hour between 8 a.m. and 7 p.m. And it was coded incorrectly, something called a non-sargeable operation. So SQL Server was literally picking a CPU and running it. Took 35 minutes every time it ran, every hour and a half. That's a problem, because that was actually holding back some of the other processes running on the machine. We actually went in and fixed the operation. It spiked each individual CPU to about 75, 80%, but the thing only took about 30 seconds to run. Big difference. You'd never see this if you're just looking at averages. Now, this guy, yeah, this was a little busy. This is also why I love to look at this stuff. By the way, you can tell when people went to lunch. This thing was really busy. It was a radiology group. It was an 8-course SQL Server. They were trying to save money. And what was happening was it was kind of like a snowball rolling downhill. You'd end up with a process being blocked by another one because things were taking forever to run. And then that one being blocked was blocking 2 more. And the next one was blocking 10 more. And the next one was blocking 100 more. And you ended up with these basic operations that were taking minutes to run during production hours. And I'm not exaggerating. This was a radiology group reading radiological images for people that were sitting in a CAT scanner in the emergency room after car accidents and things like that. I cannot say who this was, but I'm telling you that lives actually depended on this, and their company was trying to save about 20 grand. Yeah, I don't have a lot of nice words for that. Okay, now we're going to get the nuts and bolts behind this stuff. Let's hit the instance level. So step 0, pull up SQL Server Management Studio and connect. You're going to see these numbers right here that I mentioned a minute ago. So in this case, 15.0.4123.1. No problem. What does this actually mean? Well, go to SQLServerBuilds.blogspot.com and you're going to come up with a grid like this. This is going to tell you every single patch that SQL Server has ever put out. Where are you at? So let's just say, I'll zoom in here so I can draw. Let's just say that I'm running SQL Server 2012 build 11.0.6280. Okay, so I know that's between Service Pack 3 and Service Pack 4 for SQL Server here. You can also see there are 10 cumulative updates that came out after that Service Pack. These don't get delivered via Windows Update at all. So it's up to you to go periodically review this, make sure everything looks good. It's just a simple link that you can go download. And if you scroll a little bit further down the page, you'll see the exact build number, the exact link, and all the release notes and when it came out. This is really important because, I mean, step number 1, is the SQL Server that you're running still in mainstream support or is it in extended support? If you're running a SQL Server 2008 or 8R2, I'm sorry, Microsoft will no longer support you. And if your business ever gets hacked, that is a major security liability. So be careful with that. SQL Server 2012, actually I'll back up. 2012 goes out of support July of next year. So if you have any of these, you need to start working on a migration plan for these. Now, download the latest cumulative update, take a VM level snapshot of your virtual machine before you go actually apply this. 99.9999% of the time, they're perfectly fine. Just so you know, service packs were issued for SQL Server up to version 2016. Starting with version 2017, there are no more service packs. They're just cumulative updates. Get these in there. Make this part of your routine. They're shipping cumulative updates roughly every 2 to 3 months. It is well worth your time. Give it some time to bake after they release one, but go get these in there. Don't slack off on it. Do these 2 to 3 times a year. It's worth it. There's new functionality that's being added. There's a lot of security bugs that always come up. There's less than other Oracle or other DBMS platforms, but there's still stuff that comes up that we need to patch for. Okay, so now
Let me interrupt you real quick.
yeah.
So Adam Marshall made a comment. SQL Server does update through Windows Server Update Services and probably also through Windows Update. However, there would be optional components for Windows Update alone. Cumulative updates are shipped through WSUS.
You're correct. WSUS does do those, but because they have greater capability than regular Windows Update. Cumulative updates are still not delivered through Windows Updates directly. WSUS will do that, but the only time I've ever seen anything SQL Server related coming straight through Windows Update was an out-of-band security update about 6 to 7 months ago. Other than that, they will not push that directly. If you've got Windows Software Update Services, definitely look at it. It will take SQL Server offline when you go apply those, so be careful. I'm partial to running those manually just because I like to go look at the error log and make sure everything comes up after I run one of these things. Now, how to read the error log. If you expand management and then a SQL Server logs, you'll see a handful of error logs here. These get recycled every time you restart your instance. I like to go recycle these nightly on some of the more active environments, but there's two ways to do it. One, if we're here and you go management and then SQL Server logs, if you just double click on the current log, and I'll zoom in here so you can see this. Oops, wrong screen. There we go. So you can actually see, you can select the file that we care about, and then here's all your entries in reverse chronological order, and there's all kinds of stuff in here, and you can see that the toilet database makes its ugly appearance again. Log type SQL Server. There is also a SQL Server agent error log here. That's the agent related to your job schedulers, and I'll show you that here in just a minute. The stuff that I care about, there's two logs to check. You need to check over this periodically. Look at the agent error log. That's down at the bottom. I'll show you that. And I always make a funny joke. If you're looking through this and you see something that's just a little funny, does it pass the sniff test? Does it just not smell right? And this is one of those areas that just start to poke around there. You're going to find things that don't make sense. A really quick check on Google is going to tell you, because people are going to hit this stuff before. A really quick check will say, is this normal or not? The biggest stuff that I really want you to watch out for is right after you start, there we go. Right after you restart this thing, it's going to give you something right here. And I'm going to expand upon this in a minute, but this is your CPU presentation to the virtual machine. I catch misconfigurations with this almost every single week, and this goes a long way to making sure these things are running well. The other thing here, if you want to run this from a command line, from the query window, XP_read error log is how you do this. So if you're here, all you got to do is go new query. And now we run this in the context of a database. This one you can run from anywhere, but if you notice, I can drop this down and I got the ability to run a command in any of the databases on there. So literally all you do is XP_read error log. It's Control E or F5 or click execute here. And that is your entire error log since the last time this thing was restarted or the last time the error log was cycled. So this is that command I was showing you right here. SQL Server detected one socket with 8 cores per socket, blah, blah, blah. That's the thing we care about. And then this guy right here, but I'm going to go more into details on that here in just a minute. Okay, if you want to programmatically do this, so actually, let me step back. The SQL Server agent error log is here. And where'd that go? So if I look at the agent, and I'll zoom in so you can see where this is at. So here's my agent. I have my scheduled jobs. So you can see I'm doing database backups, I'm doing index optimization, integrity checks, that kind of stuff. I can set up alerts for different things. I can define an operator, and that way I can just say, hey, this person or this group goes to this email distribution list. And then there's error logs right there. So I'm going to expand error logs and hit current. And you can see this is SQL Server since the last time I turned this thing on. So, a handful of things in here. Unable to start mail session. Okay, that's something to look for. Unable to refresh database mail profile. Reason, no database mail profile defined. And that's intentional. I'm on a workstation, I don't care. But for production environments, we need to go take a look at that. So these are all things that you want to go scan the error logs to look for. By the way, if you want to configure an email relay on here, right here at the instance is database mail. All you got to do, double click that, say next. I want to set this up, and then it's not available. Do you want to enable? Yes. So you go in here and you create, it's basically just a normal email relay. So you profile name, you set up the SMTP account wherever you want to send it from, email server, all the usual stuff. Once you do that, then this thing can start sending emails to let you know if jobs have failed, things like that. The operator, same kind of thing. So if I can type tonight, you can see create a new operator, pick a name, pick an email address, same kind of thing. And I'll go ahead and do that here just so we've got it in there. Hit OK. And now instead of saying on a job, actually, I'll just show you here. So if I want to figure out if this thing has failed, this is system database full, no problem. Go to notifications. Hit notifications, and you'll notice here, I have the ability to send myself an email if this thing failed. So check the box. When you drop that down, now that is my operator. So you can drop that down. And of course, I think I just hit a bug in SQL Server Management Studio, and I did. That's fantastic. This is also why you want to keep these things up to date. That's hilarious. That's going to get reported to Microsoft as soon as we get off the phone tonight, because that was silly. This is why I don't do a lot of demos and conferences. Okay, show you where that's at. So notifications, email, drop that down, pick the user, and then literally that's it. And if this thing fails, you can have this. Normally I'll do for production machines like default operator or email IT alerts or something like that. You have it sent to a distro list or some workflow management that is built to handle this stuff. If you're running a syslog collector, you can also write it to the Windows application event log, and that will get picked up and actually presented there appropriately. Okay. Jump back into that. There we go. Okay, so I showed you that. If you want to run this from T-SQL, the command here, so xp_read error log space 0, 2. 0 says read the most current log. 2 is SQL Server agent. 1, if you wanted to specify a 1, that gets you the main SQL Server. Now, here's the fun part. If you ever wanted to search for keywords in here, like things like fail, or error, or timeout, or warning, or Joe is a bad admin, or however you want to search for this stuff, you can do this. So one of the things I like to do is once you get a sense for how this thing is running, you can actually do an automated report to say, give me a whole bunch of these and give me the results. So do I have any errors from yesterday? Do I have any failures? Do I have deadlocks, anything timing out, long IO warnings, all this kind of stuff? If you're really interested in doing this, let me know. I've got about 25 keywords I normally look for. But it's common stuff like this that I want to key in on, because usually that means it's something is brewing, and I don't like that. I actually used this morning. Yeah, cloud is perfect, right? There's a physical machine at Amazon underneath a virtual machine that I was building a SQL Server high availability solution for that was having an absolute conniption and was causing database corruption. Not a good day. So that process is stopped, and that migration might actually not happen this weekend, which I'm not exactly sad for. Cool. Okay. Are there any questions on just where key stuff is at inside SQL Server? I think we're good. Okay. One of the biggest, most challenging misconfigurations that I see that really matters for SQL Server that might not be the most intuitive is with virtual machine NUMA. For those of you not familiar with this, what NUMA is essentially is a SQL Server's CPUs and how they're presented to the virtual machine. If you're still running physical SQL servers, you still may have NUMA. If you have multiple sockets on the main board, that's multiple NUMA nodes. So it's a socket and the cores inside the socket. If you're running VMware, Hyper-V, Nutanix, KVM, whatever, you still have to worry about all this. Really common misconfiguration. Step 0, understand the right sizing allocation. So if I got a 12-core, 512 gig of RAM physical machine, my physical machine NUMA node, 12-core, 256 gigs of RAM. If my virtual machine fits inside one physical socket, build the VM for one socket with that number of cores. Be careful with this, please. If the vCPU count does not fit in one physical NUMA node, split the VM in half, build it for 2 sockets by half the number of cores. And if you take a look, this is my home lab here. I'm just going to show you where this is at. I'll zoom in here so you can see this. So let's just say I want let's just say a 20 core virtual machine. If you've never expanded the CPU architecture here, please do, because you now have the ability to define sockets and cores per socket. That is a default value in VMware, which is absolutely absurd and stupid and idiotic. By the way, VMware 6.7 and above don't actually listen to you here. It actually looks at the physical machine hardware topology and will figure out how many CPU cores you need, not what you told it to do here. Most of the time it gets it right. Occasionally it gets it wrong. When it gets it wrong, it's bad. If you're running VMs that are vHardware compatibility 6.5 or earlier, or ESXi 6.5 or earlier, or Hyper-V 2012 R2 or earlier, this kind of stuff happens where it can just be off. So the easiest thing to do is literally, this is a 12-core physical machine per socket, 24-core total. So here, I want no more virtual machine sockets than exist on the physical machine. So in this case, I want 2 sockets by 10 core. That lines up appropriately with the underlying physical machine, and life is good. Now, let me show you why this matters so much. SQL Server has to deal with NUMA. So does the operating system. So does the hypervisor from a CPU scheduling standpoint. So does the physical machine with CPU core parking and things like that. Check this out. SQL Server Standard Edition, which arguably most of you have, is limited to 24 total addressable CPU cores or 4 CPU sockets worth of cores, whichever is less. I have got hundreds of screenshots of SQL servers with 20, 24, 16 cores, and they're only able to use 4 or 8. And a lot of times Windows and SQL Server argue about which cores they can't use, and you'll end up with Windows kernel time that's really high, CPU consumption is through the roof, and everything is slow, and nobody knows why. Now let me show you how to go check this. If I open SQL Server, I'm going to show you where I can actually go look at my NUMA nodes here. And what I want you to do is to figure out, is this what I expect? So if you're here in SQL Server Management Studio, right-click on the instance, hit Properties, go to Processors, and I'll zoom in here in a second. And if you are under, there, a little sensitive there. Okay, and Processors, expand all. Now I can see my NUMA nodes. These are the individual cores in the NUMA node. Now this is on my workstation. It is hyper-threaded, so you see 16 cores there, but it's really 8 plus hyper-threading. If we have a NUMA misconfiguration, you'll actually see a bunch of NUMA nodes in here, and that's not that good. Now, if we want to go check this stuff out quickly, I can use a dynamic management view to go look at this stuff. So now, here you go. Literally select stuff from sys.dmos nodes. And I'll show you this here. So if I open a new query window, and you don't have to type all the extra stuff in there, it's literally select star from sys.dmos nodes and execute. And you can see, this case, I have one NUMA node. It's online. Memory node ID matches my node ID, which is a good thing. Online scheduler count. Now I'm going to zoom in a little bit more over here. My online scheduler count equals my idle scheduler count, which is good. If some of these CPUs were not being used because of a NUMA imbalance or a SQL Server licensing limitation, you'll actually see, you'd see like 8 here and 16, or it'd have multiple entries and maybe some of them's listed as offline. So just run this. If you see this online DAC, ignore that. That is the dedicated admin connection. Everything's okay there. You can just safe to ignore. Now, there is another state in SQL Server called automatic soft NUMA. This is new as of 2016. It's kind of interesting. Yep, I have a slide on this. So 2016 and above, if more than 8 cores are available per NUMA node, SQL Server doesn't like to parallelize that wide. So it just says, yeah, if I got more than 8, yeah, cut them in half. Give me more than one NUMA node. You'll actually see this in the error log at startup. It says automatic soft NUMA was enabled because SQL Server has detected hardware NUMA nodes with greater than 8 physical cores. When this happens, you can get some interesting, strange behavior. Now, let me give you an example of this. a reporting environment at a particular company had 8 cores. No problem. It was a 16 core by 2 socket physical machine. Okay, so they had just bought another company. They were adding users on there. Things are running a little sluggish, and they wanted to go from 8 to 10 cores. No problem. So they moved it from 8 to 10 cores, turned the VM back on, and things were running about 40 to 45% slower than they used to. It's like, huh? Doesn't make any sense. So they rolled back, they went back to 8 cores, and everything went back to normal. They went back to 10, everything slowed down. Why? This kicked in. What it did, they crossed that 8 threshold, and SQL Server goes, I know better than you, so I'm going to just split this thing in half and give you a 2 soft NUMA node environment, each with 5 cores. And since SQL Server likes to pin a workload to a NUMA node, it goes, hey, you used to have 8 cores to run this report before, now you only have 5. 40% performance hit right there in 3 clicks. Stuff to watch out for. Most of the time, not that big of a deal. Now, the NUMA nodes and parallelism get really interesting. There's 2 big settings that I care about. One is called the cost threshold of parallelism, and the other is the max degree of parallelism. These are things that we need to go look at. The very first here is the cost threshold of parallelism.
Quick
So if,
question, David.
yeah,
Adam Marshall is asking how to fix that soft NUMA thing. Is there a way to
it's
deactivate that?
there is a way to deactivate it. There is a trace flag for that, but I don't want to tell you to blindly disable it. It is very specific to your workload. So the easy way would be to quite literally change the VM architecture if you think that it's killing you, or Google search for the trace flag for how to disable that. And you can actually turn it on or off, and then just run these big reports and see if they're actually holding you back. They put it in there for a reason. A lot of times you get limiting factors for SQL Server beyond 8 cores. But I mean, like the previous example, yeah, you could probably get rid of it and be perfectly fine. But let's say you're building a 32 core SQL Server. Is it better to have 2 16 core NUMA nodes or 4 8? It's very specific to your workload. So test and verify, but there's a trace flag to turn it off, and you can just undo the trace flag to turn it back on. Cool. Okay. Parallelism is a fascinating topic, and I'll be blunt. If you Google search for this, you're going to end up in a lot of flame wars. And I choose what I say here carefully because I know we're being reported or recorded. Um, with SQL Server in this particular setting, there are a lot of highly opinionated DBAs out there where they will make a lot of blanket rules that says, this is your solution. This is the number you need to set this to. There is no right answer for this. What this value actually is when SQL Server gets a command, any old statement, it will compile it, and it's going to tear it apart, and it's going to figure out how complex that value or that query really is. And the more complex it is, the higher this value. If that value is greater than or equal to the value that I've got selected on the screen here, SQL Server will attempt to grab a number of CPUs up to this other setting called the max degree of parallelism, and it will attempt to parallelize that query up to that number of CPUs. The default value in there is 5. There used to be a unit of measurement to it. There's not anymore. That value has been in there for a long time. Now, a lot of people on the internet say that that value must change. I'm not going to tell you that. It's very workload specific. Most of the time, I find that that value is too low, where SQL Server is trying to parallelize a very basic command. And believe it or not, because of the overhead of query parallelism, it's actually faster to just pick an idle CPU and run it than it is to try to parallelize it, tear it apart, grab the data with multiple worker threads, put it all back together, and hand it to you. Now, where that threshold is at gets really interesting, and I could spend the next 2 hours just showing you how to tune for this query. Email me if you want directions. I can show you how, but it's too long for what we've got here. But basically, there's no blanket rule for this. My starting point for machines that I've never seen before is a value between 25 and 50. And what you can do, you can actually replay these queries and specify query parallelism with and without, and you can actually dial this in, and that's the process for tuning this. For machines that I've never seen before, quite frankly, I started 25. A lot of other people started 50. It usually makes a difference for like 4 queries. It's not that big of a deal. A lot of people freak out about this. So if your value here is a value of 5, I would start to investigate, does it warrant changing? And again, message me, I'll work with you. I can send you some directions on how to actually go tune this, because it does matter for the big, really aggressive commands. Most of the time, most of these things are really lightweight. It doesn't really matter that much. Now, if it goes parallel, this setting here, max degree of parallelism, this is how many CPU cores this will attempt to parallelize up to. 0 means everything. Newest versions of SQL Server 2017 and above will actually put the number of cores on the machine. Once you get to 8, it stops there. Feel free to change this as your workload demands. I usually don't like to see this above 8 unless you have a good reason for it. Okay. There we go. Yeah, my recommendations, and always go past 1. If it is a single NUMA node on the virtual machine, put it for the number of cores or 8, whichever is lower. And if an individual command is consuming everything on the machine, start to rein it in a little bit. This is how you do it. If you have multiple NUMA nodes, set this value to the number of cores in one NUMA node or 8, whichever is lower. SQL Server likes to pin a workload to a NUMA node. If hyperthreading is enabled, make 8 16 and go from there. And you can actually see when these long-running commands run, your CPUs are going to spike. Dial this in. Be careful with this. Don't disable parallelism. Some people like to do this. I don't like to do that. If you're running SharePoint, it's required that you disable parallelism. So just be careful with that. There is a maximum memory setting in here. The SQL Server, if you've ever looked at a SQL Server running process, the memory footprint on it is ridiculously large. There is a value in here called the maximum server memory setting, and this is how you can rein SQL Server in. All the RAM is basically a storage recache. There's an assumption in SQL Server that all working set data will be run out of memory, so therefore we need a lot of it. And it doesn't just kick it out when it's done. It holds it there in case the query is going to be asking for this data again and again and again. This is why SQL Server eats so much RAM. Leave enough headroom for your operating system. Use the Windows Available Memory Counter if you want to gauge where you're at with that. But go set this properly. The default is like 2 petabytes. It's some ridiculous number. Set it to roughly 75 to 80, maybe 85% if you have a lot of RAM of the available memory on the machine. And then watch that available memory counter to go dial that in. Because if Windows is pressuring SQL Server too hard, whatever you do, do not set the max memory to 0, which in this case is not unlimited. You are absolutely correct. That is a bad day. When you tell SQL Server that it cannot use any memory at all, it generally doesn't want to even turn on at that point. And by the way, the value is in megabytes and not gigabytes. So 128 megs is not the same as 128 gigs, so be careful with that too. I've even done that on my workstation. That was not fun. Now, here's the interesting thing. These memory stats are not going to show up in the process memory inside Windows, not like you would expect with the pages per second, page reads per writes. They don't show up there. They're actually SQL Server instance specific memory counters. Buffer cache hit ratio is one of them. Essentially, when we're running a command, what is our read cache hit ratio during the given day? Most of the time, it's going to be like 99.9 something percent, because, I mean, if you got a terabyte of data, you're not reading all that all the time. People are commonly reading little bits of data for things like, drop downs on a screen, stuff like that. That's normal. There's another one in here called page life expectancy. This is what used to be the rough measurement of how long a block of data stays in memory before it gets kicked out to make room for more data. If you Google search for this, you're going to find people saying 300 is where you need to be. It's like, no. 300 seconds. If you got a terabyte of RAM, if you're flushing it every 5 minutes, you're not doing something right. So Higher is better to a point, but if it's too low, what you're going to see is that your SQL Server read activity on disk is going to skyrocket, and your performance of all your running commands are going to suffer. If it's too high, that means everything that you've got is in RAM and it's just sitting there. Some DBAs like this, but from a VM admin perspective, that means I'm going to get less density on my physical machines. It might not be advantageous. So how fast is your storage? If your storage subsystem is blazing fast, everything might be okay. It might actually be able to keep up. So be careful with this. That's another really good question. If my virtual machine layer vCPU is 2 NUMA nodes, what does it show inside SQL? Either a single NUMA node or 2. Nick, can you help me remember to answer this at the end? Because that
Yeah,
question might take a while to answer.
sure, no problem.
Cool. Not trying to not answer it, Deepak. I'll definitely answer it, but it might take a few minutes. Cool. Now, something that DBAs have to do every single night or week, depending on where it's at, is routine SQL Server database maintenance. You might see, if you're looking at things like SCOM or SolarWinds or vRealize, something like that, these things get really busy at night. We got to do database backups frequently. It's not just a full database backup. We also have to manage that transaction log that we were talking about. There's also index fragmentation. So realistically, think of a database table like a phone book of New York City. What if it's only in the order at which people were born or moved to town? If you want to find John Smith, you got to look through the whole phone book, page by page, record by record. And even if you find one, you got to finish all the way to the end in case there's 2 or 3 of them. The indexes that are put into these things is how we're able to sort this data in a way that we care about. What if I'm sorting by social security number, which I hope you don't have in the database, but it's got to be there somewhere, or an ID value of when it was created, or like the phone book. Maybe I want to sort by last name, comma, first name, comma, state, city, zip, whatever you want to sort by. There's probably an index in there that will help you do this. It's just a pointer to put it in the order that we care about. So instead of having to scan the whole table, we can jump to a certain spot and get our data. Well, every time you change data in the database, that's got to be updated. And we got to go do this periodically, or else the SQL Server engine goes, hey, I know my data is right there. Oh, no, it's not there. Okay, now I got to read the whole thing. It takes forever, a lot of disk activity, not the most fun. So we got to do index and statistic fragmentation cleanup, basically. Some folks do it weekly, some folks do it nightly. We got to do it. And then there's integrity checks. If we've got a storage hiccup underneath or something's not right, you could end up with a block of bad data or more. If that's there, there's a chance you just lost data. And from a data management perspective, that's one of the worst things that you can possibly do. Some of these things can be a real pain to clean up. Other times the data is just gone. And if you don't catch it for a while, maybe my last backup that had good data in it got flushed out 2 months ago, and now that data is toast. And what if I need that for an audit? And that's bad. That's really bad. Now, how do we do this? We got to figure out the frequency to go run all of this stuff. So full database backups, if the databases are small, small is relative, small means I can run this in a period of time where it's not going to impact anybody else. Do it daily. If it's big, meaning it's going to take a while to run this thing, do it weekly. If you're doing this weekly, you should still do a differential database backup nightly. And this is going to go give me what has changed since the last full backup. And then we got to do our transaction log backups. Think of it this way. It's a record of what has changed in the database. So if I'm running database transaction log backups on the hour, so literally on the zeros of the hour, and at 1:57 p.m., my SAN just died. You haven't backed up that data in 57 minutes. That's 57 minutes of data loss that's in your environment, and that's a really bad day. Or if you do your transaction log backups more frequently, one, it's going to keep the size of these things in check because it's got less it's got to hold on to. And that means that you have more frequent backups, so I have less window. If I do every 5 minutes, which is what I like to do, if it died at 157, you lose 2 minutes worth of data. That's still not good. That's a whole lot better than an hour's worth. Now, index optimization, I like to do it nightly. Other folks like to do this weekly. It really does depend on how much data you've got and how much data is changing. Integrity checks on your system databases, I prefer to do these weekly, or excuse me, I prefer to do these daily. If I'm doing my user databases, probably weekly at worst. They do take a lot of time to run. It will beat up your storage and your memory when this thing runs. Really good question from Luther. Can you incorporate this into your third-party backups like Veeam, for example? The answer is, standard DBA answer, it depends. Some backup systems, and I will single out Veeam since you did, Veeam can do what it claims to be transaction log management. But what it's actually doing is getting a file level pointer and not actually doing full transaction log handling. So here's the thing. If I'm doing, let's say 1 hour Veeam backups with database transaction logs, and same thing happens, poop hit the fan at 157. Veeam would give you the ability to restore to 1 p.m. If you're doing SQL Server database transaction logs, I can restore to 155. But now let's go a step further. Let's just say, oops, I got tired, I made a typo. Instead of delete from table users where ID equals some really big number, what if I accidentally just said delete from table users, go? Whoops, problem. It happens all the time. With a proper database transaction log backup, I now have the ability to say, restore this database up to 155 and 12 seconds and 18 milliseconds. And I can literally inch up to the millisecond before a severe command occurred, and I have point in time recoverability. Some utilities like Veeam cannot do this very well. Others like Rubrik can. It really, and Commvault can do it, and a few others can do it. Your mileage may vary with a server grade backup application and how it can handle SQL Server management. So to me, the way I look at it as a career DBA, if you can back up a SQL Server database and recover to a point in time, then I think you're fine. If it can't go to a point in time where it's literally doing, whenever the backup was running and nothing in between, that's not good enough. So a lot of times, Veeam specifically, I'll actually go and disable the application aware portion of Veeam, and I'll do native SQL Server backups, and I'll run Veeam for the VM level backups because I think Veeam is great for that. It does a really good job. I use it all the time. But from a SQL Server perspective, it's that intermittent, that interval that it just can't do very well. So long-winded answer. Hope that answered that for you. Okay, maintenance methods. A lot of people use maintenance plans. Go ahead, Nick. Sorry.
I was going to say, with the transaction log backups, I feel like there was a period in time where I was reading up on shrinking the database to flush out different things. What's your opinion on that?
Good question. So another long-winded answer, but bear with me. And I think I actually cover this in a little bit, but I'll cover it now.
No worries. I mean, if you want to wait, up to you.
No, I'll answer it now where it's topical. There's two things that you can shrink. One is the database data files, and the other is the log file. If you shrink the data file, I personally don't like to do this on a frequent or scheduled basis. But let's just say, somebody at the end of the year, they're done, they got rid of a bunch of archival data, stuff like that. To me, shrink the database, reclaim the space, no big deal. Do it as a one-time operation, no problem. Now, the transaction log is a little bit different. A lot of people, transaction logs grow over time. It's just part of what they do. Like an index rebuild, All of that is in the transaction log, so it's fairly big. A lot of people get in the habit of automatically shrinking a transaction log on a daily basis to get the space back. Well, point blank, it's just going to do it again. And every time that it shrinks, it keeps track of the pointers. Every time that file grows, every single auto growth operation, and let me actually show you where that's at in here. So if I expand the databases, I'm going to pick this one because I know it's kind of big.
I feel like we used to have to shrink the transaction logs when we ran Epicor, and maybe that was the wrong way to go about it.
Um, it's not a great way to go about it, to be frank, but a lot of people do it. Most of the time, they don't notice a difference, but here's what it is. This thing right now is just over a gig, grow by 64 megs. So if I pump in some massive transaction that's going to eat a lot of space, this sucker's going to grow and grow and grow and grow and grow. Every one of these growth operations creates something called a virtual log file segment, or VLF. The interesting thing here is that every time SQL Server turns on, it has to go through every VLF as part of its crash recovery process to get the database back online. The more of these that you have, the longer it's going to take. Now, there's a rule of thumb: you want 200 VLFs or less. Anything under 1,000, to me, you're not really going to notice a big difference. I like to keep it under 200 just as a rule of thumb. We had one, a SQL Server was taking 8.5 hours to restart. Yeah, yeah, exactly. Company called up. They're like, "Can you help us? Can you get it below 4 hours?" It's like, we can do better than that. Went and looked. They had 8.5 billion virtual log file segments on a 10 terabyte database. And every time SQL Server came back up for routine patching, all that jazz, it had to go through the whole thing every single time. So if it happens, right click, go to tasks, go to shrink, go to files, go to file type, log. And then what you can do is you can actually select this guy and knock this all the way down to like 1 meg, as low as you can possibly get it. And then as soon as that's done, go back into the database settings, go back into properties, files, go here, change that number, blow it right back up to where it was at, but increase this auto growth value from 64 to 128 and 256 megs, something like that. The default is 10%. It starts at 1 meg. So by the time this file is a gig, you've got what, like 700 or 800 VLFs in there? That's not good. So the default, go change this stuff. Easy to go do. If you find that the VLF count is huge, and there's a query in here in a few minutes, I'll show you how to go get that count. That's how you go detect that stuff. So I'll come back to that here in just a few. The maintenance method that I like is called the Ola Hallengren maintenance solution. He's a DBA out of, I believe, the Netherlands. Phenomenal gentleman. He's got this really cool script that he gives away. It's out at ola.hallengren.com. All you do, so the maintenance that you saw on my machine here, this is what it does. Database backups, integrity checks, index optimization, couple cleanup jobs, done. No problem. The maintenance plans that ship with SQL Server, quite frankly, are not very good. They're not very smart. There's not a lot of good logging in there. That's actually how I spent my morning this morning, trying to figure out what was breaking in this maintenance plan with about 20 steps in there. Not the most fun. The Ola Hallengren solution is completely free, very customizable, just works. We've got some really big environments with tens of thousands of SQL servers. This is what they use. It's easy to manage. Or if you have really specific requirements, roll your own. You can actually pick and choose pieces of each of these to use if they make the most sense for you. I prefer the Ola Hallengren one, and then you can tweak it from there. Now, the diagnostics from a lot of the stuff, the queries that you're going to see from here on out, most of these I've tweaked a little bit from, they're freely available at glensqlperformance.com with 2 N's. Page looks like this. SQL Server informational diagnostic queries. They're completely free. He updates them every single month. They are absolutely amazing. Grab the version that corresponds to the major version of SQL Server that you're on. And you'll notice here, there are some changes that Microsoft made with Service Pack 2 in SQL Server 2016. So use that SQL Server builds.blogspot.com, figure out which one you're on, grab the appropriate one. Step number one, once you have your diagnostic queries, when were my backups executed? And those command packs, those queries, are actually in there, and you can literally copy and paste this stuff. So when was my last backup? And check this out. This was from my machine that you're looking at right now. So HFX, just a bunch of different databases that I've got here. Last full backup, last log backup. Some of these are in simple mode. I'll talk about that here in a minute. They actually don't get log backups. Doesn't matter from a production database standpoint. So go scan this. You'd be surprised. People use maintenance plans and they whitelist databases to say back this one up and back this one up. And then tomorrow, somebody adds another database. Uh-oh. The Ola Hallengren stuff will automatically pick these up if it's configured to the default of all user databases, and it just grabs it. Be careful with this stuff. I mean, literally the health check I was looking at over the weekend, company had a 120 gigabyte database with a 2.1 terabyte log file because they had not accidentally told it to do backups properly. And the log was just growing and growing and growing out of control. Now, let's figure out when the last time we were doing an integrity check. So there's a PowerShell module out there. dbatools.io is where you can get it from. It's also part of the Windows PowerShell gallery. So literally install -module space DBA tools. If you go run this, so get DBA last good check DB. SQL instance is my machine name. Credential could be you, could be SA or whatever login you want, and then format table. So here's my databases. When was the database created? Last good check DB. Temp DB does not get a check DB, no problem. But were these run recently or not so recently? If they were not yet run at all or within the last couple weeks, they need to be run. Okay. And I'm running through this because I know we're on time, but told you, Nick, it was going to be hard to keep this to an hour because there's so much in here.
That's all right. You're doing fine.
Agent jobs. We've got all kinds of jobs. One, are they scheduled, to run on a normal periodic basis? And cool, if so, great. Are they set to notify you if they fail? A lot of people miss this, where if I've got database corruption, and it's checking for it. Maybe it's letting me know that, hey, you got to go do something about this. And it's not alerting anywhere and nobody's watching to see what has failed. Keep an eye on this stuff. Anything that's important, set this thing to email you. It's just an email. It's not going to kill you if you get a couple of them. And I want to know if stuff's causing a problem before it's causing a problem. And then the other thing, is email configured? And I already showed you how to go do that. Another real quick thing, suspect pages table in the MSDB database. If the database engine has ever encountered corruption, you'll see an entry in this table. And it's literally copy and paste this query or literally select star from msdb.dbo.suspect_pages. If there's anything in there at all, look at the last update date, figure out if this is really old and somebody already took care of it, but they forgot to remove it from here, or do we have corruption that we really got to go watch out for? Actually, somebody from my company just had to repair this for a company just a couple of weeks ago. They had corruption, they weren't checking for it, they weren't watching for it, and it had happened over months. Nobody caught it. And the last good backup that they had was 4 months prior. So we had to figure out where the corruption was, how to stop it from happening again, and how to take the data from the super old backup and merge it into this new database to fix this stuff. Cool. TempDB, already talked about all of that. I would love to see multiple data files in here. The default are more than one, so literally up to 1 per CPU or 8, whichever is lower. Because this thing is stomped on by so many things, I may end up with what's called metadata contention inside SQL Server. This happens with a lot of highly concurrent active databases. The default in SQL Server is to create multiple data files. It helps the database engine spread this load out, and you end up with a really good parallel stream of activity. If you have really highly concurrent databases, this is why it's good to do those there as well. But TempDB, we do it by default, and SQL Server has started to do this. Just make sure the auto growth rate is the same and the initial size is the same. That helps cut down on a lot of contention in there. Database level stats, I want to look at a handful of things. This query will give you the list of databases and their files and their locations, as well as the auto growth rates and the current size. So little things. Is the log file bigger than the data file? If it is, maybe it's not getting backed up properly. Sometimes it is, sometimes it's not. Go watch out for that. Look for anything on the C drive. I don't want to see any of the stuff on the C drive. If it is, you can detach a database, move the files off, reattach it in SQL Server. If it's a system database, it's a little more involved, but it's not that bad. Look for anything that has a 10% growth rate. That can contribute to high VLF count. So go change it. Just literally set it to 64, 128, 256 meg growth. Not that big of a deal. You can do it live. There's no outage as part of that. Look for anything massive. I've seen some of these where a single database file is like 25 terabytes. That's a problem. That's a real problem if you're trying to back this stuff up. So it's where you got to start working with those folks to try to figure out what do we need to do to actually split this up, spread it out, make things a little bit better. There are some database settings in here. Database compatibility level. If you look per database, here's the database compatibility level. So you saw back in the past, SQL Server build 15.0. something. Well, multiply that value by 10. Here's your database compatibility level right here. If you are in looking at SQL Server Management Studio, if you right click on a database, hit properties, go to options, you now see it right here. Compatibility level, SQL Server 2019. Depending on your hardware vendor, your application vendor, your database comfort, and what sort of bad, terrible code that is present inside the database, you may not be able to run it with a new compatibility level. You may have to run it as an older one. We do have a manufacturing ERP system that we work with that even though you're running on 2019 and it's fully supported, I put the database in 2017 compatibility mode because there's a couple of quirks with some of their code. It's a little bit different. You can also change this without having to modify or take an outage. You can actually go up or down whenever you need, which is kind of handy. There's another one in here. Database recovery model, full or simple. Personal preference, if it's a production database, it should almost never be in simple mode. I want to have that record of what has changed as long as you're doing production database transaction log backups. If it's in simple mode, it's going to be a pre-production environment or a database that is used for staging or that I just don't care about what has changed during the day or that can be rebuilt. And some data warehouses are like that where they rebuild them every night. They do a backup after it's done and call it good. Just keep in mind, a transaction is logged into the transaction log, even though it's set to simple mode. But as soon as the transaction is done, those pointers are reset. So the transaction log still can get fairly big in these things. It matters. Page verify option, checksum. Long story short, there were some things in SQL Server that used to say, hey, if I'm writing this to disk, don't double check to make sure it got there properly. You have it set to none. SQL 2005, they came out with one called torn page detection. 2008, they came out with checksum. If you restore a database from an old version to a new version, they don't automatically update this stuff. It's one of those things I really wish they would. Double check this list. If there's anything set not to checksum, just set it to checksum. There's no outage required from that point forward. It will check everything that it writes to disk to make sure everything's okay. There's another one here, auto update and auto create statistics. They're basically helpers to figure out where data is at on disk. I never want to see these things turned off. Realistically, there's like edge use cases for it, but most of the time I don't want to see this. Some ISVs will turn this off because they don't know any better. Some people read a bad bit of information on the internet, they'll go turn them off. Don't turn them off, leave them on. If they're off, go turn them on. There's another one here called snapshot isolation. Do we have a fair amount of time left? I know we're way over.
I mean, I can stay
Cool.
until you're finished, and we'll just record the whole thing.
Cool. I want to give a long-winded explanation for this one.
Yeah, no worries.
This is a really interesting session. Thank you, Troy. That's funny. So, long story short, SQL Server used to have some really silly defaults, and here's a prime example of this. Let's say I got two people accessing a database table, no problem. Well, what happens when they collide? So the ACID properties of a relational database engine state that you get the version of the data at the time you asked for it. So now imagine this scenario. I've got two people using a database table. User number one is issuing a really big, long-running query. It's literally a report that says, give me everything. So select star from table, go. After the command has started, before it ends, another user comes along and places a new order in the system, which puts an entry at the end of the table. How does the database engine know that the first user shouldn't receive the new row of data? Well, by default, in SQL Server, readers and writers will block other readers and writers. So in this scenario, user number two, that command to enter that data will just sit and wait until user number one is done reading the data. It's called pessimistic concurrency, and that's the default behavior in SQL Server to this day. Now, in SQL Server 2005, Microsoft, I know this is being recorded, I'm going to say this carefully, Microsoft found their proctologist, and they introduced a setting called read committed snapshot isolation, which says readers no longer block other readers or writers. Writers will still block, that's normal, but readers no longer get blocked. If you've ever seen a SQL Server command that has a with no lock, and there's actually one on the screen right here, this is how people used to work around this locking and blocking. And to this day, this is a corporate standard in a lot of places. What it actually says is in that scenario where user number one is doing the long report and user number two is adding the data, user number one would have seen the data that user number two added. That's a problem. It's called a dirty read. And they actually got data that is bad, that broke the ACID standard of a relational database engine. So imagine this if you were doing financial reporting to figure out yesterday's receipts and somebody's coming along and they returned something and they returned it right when you're accessing it. Your financials don't line up. And then you rerun the report because you're like, huh? And all of a sudden they fix themselves. Real world scenarios. I love to go turn this setting on. This is something you do need to work with your application owners to spot check. It's one line of code. You do have to kick everybody out of the database. If you Google search for this, you will find a lot of people that are freaking out over this setting. They claim that your tempDB utilization goes through the roof, all this other jazz. It's never a problem. It's not a big deal. I love enabling this setting, especially for databases that are really active. But work with your application owner, make sure everything's kosher before you actually go roll this out. It does make a big difference. There's a handful on here. There's auto close and auto shrink. Don't turn those on. That's really bad. We already talked a lot about that. Now, here's another big one. Have any of you ever had a database administrator come to you and say, your storage performance is terrible. I'm getting long IO alerts that take more than 15 seconds every single night. It's a really common scenario. And this is because SQL Server actually records its perspective on storage latency. And if a database-driven command takes more than 15 seconds to respond to disk, it actually logs this. And a database administrator is going to freak out when they see this stuff. It's called a long IO alert. SQL Server keeps track of the stuff a little bit differently. And remember when I said SQL Server's got its own database engine inside it with a storage engine? If you run this query here, you will see the average read and write latency by SQL Server data and log file since the last time that SQL Server was restarted. If you're interested, there's a script out at heraflux.com, again, no strings attached, no contact info required, that will allow you to create a temporary table and run this over and over and over again throughout a given day, and it'll track this stuff for a given time period. Here's what's really interesting. If the database engine itself is struggling to get to that file, not necessarily because of storage latency at the SAN, but because there's just so much going on there, these numbers will be higher. So a lot of times, if we go look at what's listed in either the cloud storage stats or your hypervisor stats versus what's showing up at the SAN, versus what's showing up inside Windows, versus what's showing up in SQL Server here, You're going to go from the bottom up and you're going to go great, great, not bad, total crap. And what's in between the not so bad and total crap? And it's literally this layer right here. So if you're comparing all of these numbers side by side, and you see that the SQL Server values are extremely high, but the Windows layers underneath are not bad, that's SQL Server storage contention inside the database engine. The DBAs are going to see this and they're going to blame the SAN. It might be the SAN, but look at the rest of the data to go figure out if it actually is. If it isn't, work with them, show them all the different layers. SAN says it's good. Hypervisor says it's good. Windows says pretty darn good. SQL Server problem. This is why we add multiple data files and we start to spread this workload out. These are things that you can work with anybody in your application team to actually go work through and clean this stuff up. It goes a long way there. Now, another one, missing indexes. If I don't have an index that covers the way I'm querying data, the database engine has to scan the entire table. When this does this, it's inefficient, it's a lot of CPU, it's a lot of storage activity. It actually has to read it all into RAM, which pushes other data out that has to be reread the next time it's asked for. This query right here will take a look at the database engine's recommendations for indexes that can help you make stuff quicker. Take these with a grain of salt. These are things that are not necessarily completely truthful, but if you take these, this is kind of the art form as well as the science. Start to review the list, look for common patterns in here. And you can see here's my database, my schema, my table. Equality columns would be like select star from perf data where server ID equals 1 and collection date greater than this date and time. And as part of that, I'm going to return Perfmon counter instance ID and a perf value. This is actually real from one of my databases that I use to import Perfmon data from. And I intentionally left it like this so I could be able to show this kind of stuff. User seeks is the number of times that index would have helped you. Average total cost, this is the complexity value for that given command. And you can see that's greater than that 5 default value by a lot. Average user impact. This thing is saying that if this index had been there, that would help speed up that command by 95%. Take these with a grain of salt. The query will actually combine a bunch of these and give you an index advantage. Higher means it's a more impactful query to go, or an index to go create. Be careful with these, don't over-index, but you'll find that just by 4 hours of index tuning, I can chop the CPU consumption on a given SQL Server in half. Goes a long way. Okay, VLFs, I talked about that a little bit earlier. Here's the query to actually go give you the VLF count. Again, my rule of thumb, I like to see this under 200. Again, 500, 600 is probably not that big of a deal. Again, talked about how to fix it earlier. Database hotspots, there are 3 commands here. I want to go see CPU consumption by database. Now I can go see it. Really, really cool. It gives me the CPU time. It gives me, cumulative since the last time this thing was turned on. So if I'm looking at a virtual machine, I can say, hey, this VM is the most active on this host. SQL Server.exe is the most active process on that operating system. Now this database is the highest. And with some of the other queries in the diagnostic pack, I can actually go figure out what queries are consuming the most CPU time, or thrashing the most RAM, or eating the most disk. These are the things that really matter if I'm actually going to tune these different layers. So same thing, does it pass a sniff test? Do we have a database in here that's just crushing everything else that just takes us by surprise? Why? What's it doing? That's when you start to dig in. Same thing with memory and storage. These queries can tell you. You'd be amazed at the amount of activity some of these databases can do reads and writes. We're talking petabytes worth of reads, terabytes worth of writes. Databases don't have to be that big. It can be rereading a lot of information. Memory, same thing. Of all the databases in the SQL Server buffer pool, what's holding on to the most RAM? And this is where, in this case, you can see TempDB is eating a lot more than the primary database. Why? Is it a problem? If it's not a problem, cool. If it is, drill into it. Same exact thing. Does it pass the sniff test? Okay. We have just scratched the surface on what's possible. But what I tried to do was I tried to pick the biggest, most common challenges that I see day in and day out with our consulting practice. If you can go through this list and go through your SQL servers and get a good sense, what is it doing on a normal day-to-day basis? What's actually consuming this stuff? Why is it doing this? It really does matter. And with every single thing that I always say, question everything I say, go validate it in your own environment. Look to see if there's any customizations or anything in your environment that work, and always test any production change. I know that goes without saying, but I'd rather put it in here. And if you can't see from my video, where's that? This is kind of what I need to update my profile with right now. The old pandemic too. It's worth a laugh. Okay. Thank you all for joining. Now, I want to double back and answer Deepak's question here. If your virtual machine CPU is on 2 NUMA nodes, what does it show inside SQL Server, a single or 2? And there's a long-winded answer here. If the virtual machine, so actually, do you know if he's still on?
He had to drop. He messaged me
Ah,
earlier. Sorry we didn't get
okay,
it to, but it'll be in the recording.
perfect. Well, I'll answer it for him here. If it is VMware or Hyper-V, a lot of times, if you specify 2 NUMA nodes on the virtual machine layer, if both of those fit inside one physical machine NUMA node, you'll only get one inside the virtual machine. And that's if the V hardware compatibility level is version 6.5 or newer, or Hyper-V generation 2. If you're in the cloud, they usually do this pretty well, so you usually don't have to worry about it. If the virtual machine compatibility is Hyper-V Gen 1 or 6.1 or earlier in VMware, what you end up with is, if it's 8 or less CPUs, you get one NUMA node no matter what you told it to do. If it is greater than 8, then it'll listen to you. Now, keep that in mind. Windows Task Scheduler will not tell you the right value. It actually pulls from what VMware or Hyper-V are showing and not actually necessarily doing. So the easiest way that I look at it is just get inside SQL Server. There's so many permutations in there. Get inside SQL Server, right-click on the instance, hit Properties, go to Processors, expand that out, or just select Start from sys.dmos nodes. Just take a look at what it's got there. That will tell you for sure. Whereas the VM layer is a little ambiguous sometimes between what it says and what it does.
Good
Cool.
stuff.
It's a fun topic. Are there any more questions from anybody on the call here? Cool. So I have one question for everybody. Nick, I'll let you close this out, and then I'll ask that question of everybody here.
Sure. I guess I'm going to go ahead and stop the recording, and we'll say thank you to David.